Hi and welcome everyone to this lesson in our course for solar energy. In this lesson we will discuss the solar cables and wires used in connecting the panels. So here when we are installing our PV panels, you have to make sure of some instructions. The first one, you have to avoid the touch between the positive and the negative terminal of the panel, or to be more specific, avoid forming a short circuit between the two terminals, because it may lead to damage of the panel due to the very high short circuit current. Second point is that you should reduce the distance between the panels and the charge controller or the inverter to reduce the losses. So you have to understand that this system, in the end, we will have two terminals, positive and negative, representing the output power or output voltage and the current of the whole system. So when we are, what's the next step? We are taking this and going to the charge controller. Okay, then from a charge controller we are going to connect to the batteries, and then from here we go to the inverter. So we have to make sure that the distance between panels and charge controller or the inverter must be reduced. Okay, so why? Because when the distance is reduced, it means that the resistance will be reduced, resistance provided by the wires. It means that the power losses in the system will be reduced. Okay, that's why we try to keep the charge controller and or inverter as close to the panel, as close as possible to the panel. Also, we have to allow space between panels to reduce the wind effect. So when we have strong wind, this may lead to leaving the panel from this location. So our wind here, we will allow, when wind comes here like this, we will allow it to pass through this small space. You can see there is a very small space between panels, so we can allow the wind to pass through it. Okay. Also, we need to avoid obstacles and shadow in front of cells in order to avoid the shading effect, as we remember or as we discussed before. Finally, we need to, you can see here that the enclosure of the system, here this enclosure at which we install our PV panel, similar to this one, this enclosure, you can see that we need to do the earthing system. We need to connect this one to the ground, do an earthing for this enclosure and this part, this enclosure, and for all the fixed components of the PV panel. Why is this? In order to discharge any charges on the system. Okay, so that to avoid any electric shock. We are going to use the PV structure, which is made of aluminum. It is resistible to rust. So we use this one made of aluminum. So we discussed now some instructions about installation of PV systems. We have to understand that there are two definitions. One which is called wires and the other is called cables. So first, the wire. The wire is a conductive material and made of copper or aluminum. Why copper and aluminum? Because both of them have high conductivity. Okay, so as an example of the wire, you can see this one is considered as a wire which consisting of group of conductors, another wire consisting of a group of conductors, and so on. If you look at here, we have a wire, this one, and this one is also a wire, and this one is also a wire. Okay, one wire consisting of group of conductors inside it. Okay, now you have to understand that wire representing one core or one terminal. So as you can see here in these images, we can say that the red one is the positive, one wire representing the positive terminal, another wire representing the negative terminal. Okay, and so on, and another wire which can be earthing, which is usually green and yellow, combination of green and yellow. Okay, so it is usually representing one core. Now, what is cable? Cable is a group of two or more different wires. So instead of having just one wire like this or one wire like this, we have a group of wires like this. You can see this cable consisting of a group of wires, 1, 2, 3, 4, and so on. So group of wires together in one bundle, okay, surrounded by an insulating material. In this case we will have a cable. So cable is a group of wires, or sometimes we call the cable that it consisting of several cores. Okay, it is multi-core. So if you remember in the previous lesson when we discussed the open circuit and short circuit test of the PV panel, if you remember that we had one black bundle. Inside it had 3 wires. One had 2 wires, which is the red one and the black one, and the other one had 3 wires, which is the green one, if you remember. And we said that in that video, we said that if we measure the voltage between the red one between red one and the black one, we will have the total voltage, and between green and ground we will have half of the voltage, if you remember. Okay, so a cable has different diameter depending on the number of conductors inside it. So a wire is considered as a single core, for example one phase or one terminal. However, the cable is a group of cores or wires. So usually, if you remember, in electrical system we have a 3-phase system. Okay, so sometimes we have a cable, large cable. Inside it we have 3 cores, 1, 2, and 3. Now these 3 cores, each core representing one phase. For example, A and B and C as a 3-phase core of a cable. Okay, now each one of these is considered a wire if it is alone like this. Okay, so as you can see, this is an example of solar cables. This is how it looks like. We have the red, which usually representing the positive, and the black representing the negative terminal. Okay, now this is also different cables with different millimeter square or different area. You can see here 1C, which means 1 core multiplied by 6 square millimeter square or millimeter square. So this one has an area of 6 millimeter square. And of course, area is important in selecting the cable because it representing how much the cable will carry of the current. Okay, how much current it will carry. So you'll find that the solar cable is a cable type especially designed to be used in photovoltaic power systems. These cables are high ultraviolet radiation resistant and operates in a wide range of ambient temperature. It can operate from negative 40 Celsius degree and up to 100 Celsius degree. So from negative 40 Celsius degree and more to up to more than 100 Celsius degree, because it is it is exposed to the ultraviolet and exposed to the high temperature of the sun. Now these cables are also suitable for permanent outdoor long-term use because they are available in the sun. Okay, they are exposed to the sun throughout the day. Okay, these cables are expected to be, as expected period for this cables is 30 to 40 years. Okay, under normal conditions. You will find that the cable itself, or the solar cable, the chase of the cable is halogen free. Now why is this? Because it helps this cable to become highly flame retardant, which means that it protects against, or it can withstand the fire cases. Okay, so of course the halogen free cables also are not toxic and does not have any corrosive gases. Okay, so any corrosive gas are not released in fire because it is harmful to humans and buildings. Okay, that's why we use the halogen free cheese. As an example, if you open a website, any website, and search it for solar cables, as an example, this company solar cable of 10 millimeter square CSA, which is a cross sectional area or the area of the cable. So this cable has an area of 10 millimeter square and can withstand current, DC current, up to 98 ampere, and flame retardant and halogen free. Okay, it can operate in a temperature from negative 40 Celsius degree to up to 90 Celsius degree. Okay, now if you look at the specs of this cable, you will find that it is fire behavior, it is flame retardant. It means that it can withstand the high temperature of during fire, and halogen free because it does not release any harmful gases after burning out. You will find here we have the cross-sectional area 10 millimeter square and the current rating, the rated current of this cable, the maximum current it can withstand in normal conditions, 98 amperes. The minimum and maximum operating conditions, you can see negative 40 Celsius degree and 90 Celsius degree. And the cheese color, the color of the cable itself, you can see black color. Okay, and the diameter of the cable itself is 7.2 millimeter square. So if you just multiply pi over 4, 7.2 square, if you multiply get the area, which is equal to the area pi over 4 d square, you will get 10 millimeter square. Okay, now you will find that solar cable type, it is a solar PV cable shape. It is a single core cable, one representing one core or one phase, and this one met the standards of IEC, this different standards of IEC and other standards, and this is the operating temperature range. Here we have the voltage rating, which is 1500 volt, okay, which is the maximum voltage that this cable can withstand. Okay, now we have to see now like this. If we have panels, we discussed this several times and in different ways. We said before that we have, for each panel we have positive terminal and negative terminal for each of these panels. If I would like to connect them in series, I will connect the negative with positive and take the other two terminals. If I would like to connect them in parallel, then positive with positive and negative with negative. Then we take the two terminals of the positive and negative. Okay, now the question is, how can I do this? How can I connect them together? And what I need to do in order to do this function. Okay, so before we do this, we will have just a small discussion about the standard color code for cables. Okay, so this will help you to understand the different colors used in different systems. For example, if you have a three-phase system, which is not related to the PV system, a three-phase system in general, you will find that we have the color of phase A, color of B, and the color of C, and the neutral. Okay, now if we have a single phase system which has a live part and the neutral part, or the live cable or core, and neutral cable or core. Okay, so and we have DC, which has a positive terminal and a negative terminal, similar to our PV system, and the earthing conductor or the protective earth color, and you'll find here the reference which is used for each of these colors. Okay, so you'll find here different phases. For example, if you are in the European Union, you'll find that phase A is brown, B black, C gray, the neutral light blue. Okay, for active and neutral, black or brown and light blue. And you'll find here for this dash, what does this mean? It means there is no recommendation given inside the reference itself. Okay, and for the protective earth, most likely in all of these different regions, you can see European Union, United States, Australia, China, Japan, Russia, South Africa, all of these, you will find that the protective earth is almost similar, green yellow. Okay, you can find green yellow cable is usually representing the earthing system. Okay, you will also find here some notes here which you can see, so you can just take a screenshot of this and save it to your PC, or if you have the slides you can get back to it if you would like to see or know the color of any cable. Okay, now for our system or the PV system, you can see that we are talking about the DC system. So you will see that here the positive and the negative. You can see that the positive is what color? Red, and the negative what color? Black. This is in New Zealand and Australia. Okay, so this colors is the one which I'm discussing in this course. You can see we have used red for the live part and black for the negative part, or the positive and negative. Okay, there are other countries such as Russia, they use brown and gray. Okay, so what are the tools we are going to use to connect two panels or more together? Okay, so first we have the solar cable cutter. What does this function, or what is the function of this? It is used to cut a part of the wire. Remember that we have a large long wire, so we are going to just take a part of it. So how can I cut just a part of it? Using this tool which is called the solar cable cutter. Okay, second part is the solar cable stripper. What does it do? It simply removes the insulation layer, okay, in order to add the contacts or the pin of the clamp or the M4 connector. Okay, we will see all of this, don't worry. We have the MC4 Solar Crimping tool. It is used for cables or solar panel wires from 2.5 millimeter to 6 millimeter square solar panel PV cable. Okay, so you'll see each one of these representing different cross-sectional area. Okay, so this you will find that what is the function of all of this? It is used in the end to connect between two panels. So let's see first the solar cable stripper. What do? We simply add our cable. You can see here 14, 12, 10. So depend millimeter square, 12 millimeter square, 14 millimeter square. So according to the cross-sectional area of the cable, we will put the cable here, for example, as you can see, and then we will close on it like this, and then after this we will just pull this one away. So in the end you will be able to remove the insulation of the cable. Okay, so what we are going to do with this, we just need to remove the insulation. So how it looks like when it is in motion, you will find here some animations. Here, for example, you can see like this. Okay, so we add the tool, the solar cable stripper, and then you will see that when we compress by compressing here, you will find that the insulation itself is removed. Okay, like this. So I can just remove this insulation part, and then I'm going to connect it, add a contact to it. Okay, so we will see another one here. You can see we add the cable, and like this, boom, very fast. Okay, like this. So we removed the insulating material. Another one here, you can see we add the cable like this. Okay, here. Okay, so you can see here at the beginning like this, we add it here, then okay, like this according to the dimensions. Then when we compress, you will find that the insulation is removed. Then we will remove another insulation like this. Okay, so we have here two insulating parts. For this cable, we have a two insulating part, one which is the white one and one which is the small cables or the small wires. So the this tool had two locations, one to remove the white insulation, and the other one is used to remove the insulating material of each wire. Now we have also the MC4 Solar Crimping tool. What is the function of this? You'll find that simply I'm going to add here the pin, okay, like this pin or the contact. Then I'm going to compress using this crimping tool to hold it just in place without compressing too much. Then we are going to add our wire. So we have, remember, we had the wire without insulating material. So I'm going to add this part, connect it here like this. Then I'm going to compress using this crimping tool so that this part will be added to the wire itself. Then we are going to make the crimp, and then we will have something like this. Okay, then I'm going to add it to the male or female. Then I'm going to rotate, and we will have finally the male or female we would like to use. Okay, so in general, here is the summary for the steps, and we will see a video. Don't worry, we will see a video. So we have the stripping part, which removes the insulating material. So we'll have something like this. Okay, then I'm going to connect this part, add it here, and connect my own wire. Then compress a little bit, just compress a little bit, so that it will be fixed to this part of the wires. Then I'm going to insert it to MC4. Remember, we said before that we use MC4 male and or female to connect between two panels. So I'm going to open this part, then insert this one and insert this one, and start rotating to keep it in place. Then we are going to tighten the MC4 male and female using these tools. Okay, so we have seen now the steps required to form a male or a female MC4 male and female, which we are going to use to connect two panels together. So what we are going to do now, we are going to see a video to understand the idea. So let's look at the video here. You see that this is what we would like to do in the end. We have male and female, or positive and negative, and we would like to connect them together. So we have a cable here, which we would like to connect it to the MC4 connector, and another cable to the MC4 connector. That's what we would like to achieve. So let's see how we are going to do this. Okay, so if we go here, you will see what we are going to do. We have the cable. This is a solar cutter, which will help to cut just a part of the cable as we would like. So as you can see, we cut using this tool. So we can have any length of the cable and just take a part of it using the solar cutter. Okay, then we are going to use the solar stripper tool. You can see that here we have 2.4, 4, and 6. You can see here millimeter square. 2.5, 4, and 6 millimeter square. So depending on the cross-sectional area of the solar cable, I'm going to put it inside which one of these holes. So as you can see, we put it like this, and then when I compress, you will find that the insulating material is removed. So if we get back here like this again, you can see when I compress, the insulating material is removed. Okay, now what is the next step? The next step is that I'm going to add the contact. You can see here two types of contacts depending on the crimp of the MC4 connector. Okay, so you can see we added first the contact, then we are going to add the cable like this. Okay, then we will compress like this. So you'll see what will happen in this case. You will find that the cable and the connector became one part. Now I'm going to add it to the MC4 male and female like this. Put it like this, then remove this one, rotate and remove, then put it inside like this, then rotate again like this, keeps rotating. Okay, so we will tighten it using these tools like this. Okay, in order to have our male and female tightening correctly. So we will have in the end one wire connecting to a male, which representing the negative terminal, and another one connecting to the male, which representing the positive terminal. So we can now connect them together as we would like. Okay, so here we learned about the solar cables connection. Okay, so here is an example. So we have our PN junction here for this panel and another PN junction here. Let's use the connector here. One PN junction here, another one here. Now we have what we would like to do. We would like to connect them in what? In series. Okay, in series. So if you remember that if I would like to connect them in not in series, in parallel. This configuration is for parallel. Okay, so what I need, I would like to connect positive with positive and the negative with negative. Then we take the positive and we take the negative. Okay, so we'll find that like this. If you look here, we have positive and another positive. Since they are male, both of them are males. Okay, not male and female. Female representing the negative, the male part representing the positive. Okay, so that we have here, if I would like to connect in parallel, we have two males. Okay, so we cannot connect them together. So we'll use something which is called the MC4 multi-branch connector. So we will put the first one here and the other one here. So in this case they are connected together. We will have final positive terminal. Then for the negative, we will connect a negative here and the other negative here to the also multi-branch connector. We will have a final negative. So this is in the case of parallel connection. Now in the series connection, you can see that in series we connect positive with negative. Now positive here, we took a cable here and we use the crimping tool, all of our tools to finally get a male. And for the negative, we did the same process to get a female. Now simply we will connect the male with the female here. Okay. Now then we will have two other terminals, one which is a positive and one which is a negative, which are representing the positive and the negative of the whole system. This connection is the series connection. Okay. So in this lesson, we learned more about the PV installation process, some instructions, the solar cables and wires, and how can we connect the two panels or more together. Okay.